students, welcome back. Let us continue KSET 2015 Physical Science Paper 3 solutions from question number 26. The Dirac Hamiltonian H is equal to C alpha dot P plus beta MC square commutes with. So here, as we know, alpha and beta both are Dirac matrices and M and C are constants. Therefore, H commutes with only P. So H commutes with P. Option B is correct. In the Dirac's relativistic theory of hydrogen atom, the first excited states with total angular momentum and orbital angular momentum quantum numbers J is equal to half, 1, L is equal to 0 and L is equal to 1. From Dirac's relativistic theory, the energy E is given by E is equal to mc square 1 minus gamma square divided by 2n square minus gamma raised to 4 divided by 2n raised to 4 n divided by k minus 3 by 4. Here energy is dependent on both the principal quantum number n as well as this k. The k value is k is equal to j plus half for k less than 0 and k minus 1 is equal to j minus half for k greater than 0. K is dependent on j. That means the energy is dependent on both n and j, the principal quantum number n as well as total angular momentum quantum number j. Here the core structure of energy level. So core structure of energy level is explained by n and fine structure is explained by j. Then from non-relativistic theory, we know that for a given n, degeneracy is n square, but this degeneracy is partly lifted by relativistic effects. Therefore, degeneracy exists between 2s half and 2p 1 by 2. Here n is same, n is 2, but value of L are 0 and 1, but j is same. For given same values of j, the energy levels are degenerate. And this degeneracy exists also between 3s half and 3p 1 by 2 states, as well as 3p 3 by 2 and 3d 3 by 2 states, etc. So therefore, from Dirac's relativistic theory, you can say that for j is equal to half, L is equal to 0, L is equal to 1. That is 2s 1 by 2 and 2p 1 by 2 energy levels are degenerate. The expression P minus QA cross P minus QA, where P is the linear momentum operator, A is the vector potential, simplifies to. Now let us consider P minus QA cross P minus QA. That is equal to P cross P minus QA minus QA cross P minus QA. So you simplify this one, P cross P minus Q, P cross A minus Q, A cross P plus Q square A cross A. As we know, any vector, cross product of any vector with itself is 0. Therefore, this quantity is 0, and similarly, this is also 0. Minus Q P cross A minus Q A cross P remains. But we know that linear momentum operator P is minus IH cross del. So substitute here minus Q minus IH cross del cross A minus Q A cross minus IH cross del. So here IH cross and Q are constant. IH cross Q, del cross A plus A cross del. Now let us consider P minus QA cross P minus QA operates on psi, that is IH cross Q del cross A plus A cross del psi, that is equal to IH cross Q del cross A psi plus A cross del psi. Simplify this one. Del cross A psi means del cross A into psi plus del psi cross A plus A cross del psi. But here this quantity A cross any quantity B is equal to minus B cross A. Therefore this vanishes. So this is 0. So IH cross Q del cross A is B psi. Therefore P minus QA cross P minus QA is equal to IH cross Q B. Therefore option A is correct. The Dirac matrices alpha x, alpha y, alpha z and beta are transformed into new matrices alpha x prime, alpha y prime, alpha z prime, beta prime, where T is a unitary matrix. The new set of matrices are. So as we know, under unitary transformation, eigenvalues of old and new matrices are same. Therefore this one is not true. Then second is, if old matrice, if suppose alpha and beta are Hermitian, after unitary transformation alpha prime and beta prime are also Hermitian. Therefore this one is also not true and this is also not true. And we know that for Dirac matrices alpha square is equal to beta square is equal to, so alpha x square is equal to alpha y square is equal to alpha z square is equal to beta square is equal to 1. Therefore this is also holds good for new matrices, that is alpha x prime square is equal to alpha y prime square is equal to alpha z prime square is equal to beta square is equal to 1. Therefore option D is correct. Trace of alpha x, alpha y, alpha z, beta, alpha x, alpha y, alpha z, beta for Dirac matrices simplifies to. Here this alpha x, alpha y, alpha z and beta are Dirac matrices expressed in terms of Pauli spin matrices as alpha x is equal to 0, sigma x 0. Similarly, alpha y is 0, sigma y into sigma y 0. Then alpha z is 0, sigma z 0, and then this beta is expressed as I 0 0 minus I, where this sigma x, sigma y and sigma z are Pauli's spin matrices. So it is given by sigma x as 0 1 1 0, then sigma y is expressed as 0 minus I 0, then this sigma z is given by 1 0 0 minus 1. Now let us consider alpha x into alpha y, that is 0 sigma x 0 into 0 sigma y 0, that is equal to, so this into this into this, that is sigma x sigma y. So second element, so this way, so it is 0, so here again it is 0, then it is sigma x sigma y. So as we know, sigma x sigma y gives I into sigma z, therefore it is I sigma z 0 0 I sigma z. Then now let us consider alpha x alpha y into alpha z, that is I sigma z 0 0 I sigma z into alpha z is 0 sigma z 0, that is equal to, so this will give here this element 0, then again, so I sigma z square, then this into this, so here also it is I sigma z square, then the last element is also 0, so it is 0 sigma z square is I, that is capital I, identity matrix I 0, that is 0, I is common, 0 I 0. Now let us consider alpha x alpha y alpha z into beta, that is I 0 I 0 into beta. Beta is nothing but I 0 0 0 minus I, so that is I is common here, 0 into I plus I into 0, that results into 0, and 0 into 0 I minus I, so that is minus I square, then I into I square, so again it is 0, that is 0 I square is nothing but I only I 0. Now up to here it is complete, so alpha x alpha y alpha z beta, so again another term is there, therefore alpha x alpha y alpha z beta into alpha x alpha y alpha z beta is equal to I 0 minus I into I 0 into I 0 minus I 0, so its product is, so I into I square is minus, so here 0 into 0 0 and 0 again, here this into this, so 0 0. Sorry, first term it is minus I square, second term is 0, so third term again it is 0, and fourth term is minus I square. Now that is minus is common here, so minus minus plus, I square is I only, 0 0 I. I is nothing but identity matrix 1 0 0 1, then this one 0 0 0 0, so 0 0 0 0 1 0 0 1. Therefore trace of a matrix is nothing but sum of the principal diagonal elements. So here sum of principal diagonal elements is 4. Therefore answer is 4. Which of the following is a first order phase transition? Now let us see what is first order and what is second order phase transition. So for first order phase transition, then we can see the discontinuity in entropy as well as volume. Whereas for second order phase transition, we can see discontinuity in specific heat. And here latent heat equation holds good. It is not holds good for second order phase transition. Then examples of first order phase transition is liquid to gas phase transition away from critical point, then vaporization of liquid at its boiling point. Examples of second order phase transition is transition of ferromagnetic material to paramagnetic material, then normal liquid helium to superfluid helium, then superconducting state to normal state. All these are examples of second order phase transition, and these two are examples of first order phase transition. Therefore vaporization of liquid at its boiling point is a first order phase transition. The susceptibility of a diamagnetic substance. As we know, materials are classified as paramagnetic, diamagnetic and ferromagnetic materials depending on sign and magnitude of chi, where chi is the susceptibility given by ratio of the magnetization to the magnetic field intensity. If chi is positive, then we will say that it is paramagnetic material, and here chi is inversely proportional to temperature, and for diamagnetic materials chi is negative and it is independent of temperature. And these ferromagnetic materials are special case of paramagnetic materials where chi is positive but very large. These materials are ferromagnetic only below certain temperature. The temperature is known as Curie temperature, and here you can say that chi is proportional to 1 divided by T minus Tf, where Tf is Curie temperature. In question, the susceptibility of a diamagnetic substance. So it is independent of temperature, therefore remains constant with temperature. Option C is correct. Iron possesses the following magnetism. Answer is ferromagnetism and diamagnetism. In the random motion of Brownian particles, the Einstein coefficient of diffusion is proportional to. First, let us know what is Brownian motion. Robert Brown observed a zigzag or dancing motion of pollen grains which are suspended in water. So, pollen grains in water shows a zigzag motion. So, that is known as Brownian motion, and these motions are continuous and eternal. That is, the motion continue independently without showing any sign of stopping. Then these are completely irregular and random. Then these are independent of nature of suspended particle. But it depends on size of the particle as well as temperature. So smaller the size, more noticeable or vigorous will be the motion. Then this motion increases with temperature. Therefore, Einstein coefficient of diffusion D is given by kBT divided by 6π eta R, where T is temperature, kB is Boltzmann constant, eta is the viscosity of the liquid, and R is the radius of the particles or suspended particles moving randomly in the liquid. Therefore, this Einstein coefficient of diffusion here is directly proportional to temperature. Option C is correct. A drunkard performs a one-dimensional random walk. If he starts at the origin, the probability that after taking 6 equal steps, he will be back at the origin is. So it is a random walk problem. Let A be the starting point and B is the destination. Which is m steps away from starting point A. Then a drunkard performs a one-dimensional random walk and finally reaches B. Here let m be the distance or steps which shows the distance of A to B, and capital N be the number of steps taken by drunkard. Then probability of forward steps will be half. Similarly, probability of backward steps is half. Then probability of reaching the point B, which is m steps away from starting point A, is given by From binomial theorem, it is given by Pn. M is n factorial divided by n plus m by 2 factorial into n minus m by 2 factorial. Forward probability is half n plus m by 2 into half n minus m by 2. But here given that after taking 6 equal steps, that means number of steps taken by drunkard is 6. Then so he starts at origin and finally reaches the origin only. That means m is 0. Therefore P6 0 is given by 6 factorial, 6 by 2 factorial, 6 by 2 factorial because m is 0, 1 by 2 raised to 6 by 2, that is 3, 1 by 2 raised to 3. So that is 6 into 5 into 4 into 3 factorial divided by 3 factorial into 3 factorial, that is 3 into 2, this and this cancels, into 1 by 2 cube, 8 into 1 by 8. So this simplifies to 20 by 64. Therefore probability to reach the origin after taking 6 equal steps is 20 by 64. Below the critical temperature, the number of bosons occupying a state above the ground state varies as. So this problem is Bose-Einstein condensation. That is, for temperature below critical temperature or Bose-Einstein temperature, there is a fraction of particles condensed to a single particle ground state. So that process is known as Bose-Einstein condensation. That is, for temperature below critical temperature, the fraction of particles condensed to single particle ground state. It is not a condensation in space. It is just condensation into single particle ground state. And here it is a condensation in momentum space. Then you can say momentum is 0. And then the number of bosons occupying a state above the ground state is given by n is equal to V into 2 pi m kBt raised to 3 by 2 divided by h cube into 2.612. Therefore n is proportional to t raised to 3 by 2. Option B is correct. A silicon diode is used as a transducer to measure low temperature where the following property is measured. So here, for example, we can take our thermistor that is used to measure low temperature. That property we used are change in forward bias voltage. Therefore answer is change in forward bias. At the input, an amplifier has a signal voltage level of 4 microvolt and noise voltage level of 2 microvolt. The signal to noise ratio at the input is. So signal to noise ratio is given by square of signal voltage, ratio of the square of signal voltage to square of noise voltage, that is 4 square 16 divided by 2 square 4, it is 4 microvolt. Grounding problem include, so it is a resistance coupled devices can have interference through a common power source which is power spikes or brownouts caused by other devices in a factory. Option C is correct. The Fourier transform of a function x of t is x of f. The Fourier transform of d by df x of f will be. So here it is asked to find d by df x of f. Therefore, this function should be x of f. Though where t is mentioned, therefore it should be x of f. Given that Fourier transform of x of f is capital X of f, then x of f can be expressed as x of f is equal to 1 upon 2 pi integration minus infinity to infinity x of f e raised to j f into f with respect to df. Then consider d by df of x of f, that is 1 upon 2 pi minus infinity to infinity x of f d by df e raised to j f small f into df. So 1 upon 2 pi minus infinity to infinity x of f differentiation of e raised to j f f with respect to small f will be j into f e raised to j f f df. But here 1 upon 2 pi integration x of f e raised to j f f is nothing but small x of f. Then Fourier transform of this one. So Fourier transform of d by df x of f is equal to Fourier transform of j f x of f. Jf is common, so x of f. Fourier transform of x of f is capital X of f. So this can be written as j into this f is nothing but 2 pi f. 2 pi f into x of f. Therefore, option B is correct. A FM signal with modulation index MF is passed through a frequency tripler. The modulation index of the output signal will be. Here it is given that it is a frequency tripler. That means it triples the input. If input voltage is Vin, then output will be 3 times Vin. And also it is given that FM signal, that means here frequency is modulated with modulation index MF. Therefore, the modulation index of output signal will be 3 into MF. Option C is correct. Consider the following statements. The bandwidth of AM wave depends on bandwidth of modulating signal. The bandwidth of AM wave depends on modulation index. The bandwidth of FM wave for all practical purpose depends on modulation frequency. The bandwidth of FM wave for all practical purpose depends on amplitude of the carrier. So we know AM means amplitude modulation. Amplitude modulation wave. So if the wave has different amplitudes, then after amplitude modulation it will give wave of same amplitude. Then FM modulation means frequency modulation. So if the frequency is different, then after FM modulation, that is after frequency modulation, it will give same frequency wave. Therefore, the bandwidth of amplitude modulation wave depends on bandwidth of the modulating signal. This is true, and this one is not true. It is not dependent on modulation index. Then the bandwidth of FM wave for all practical purpose depends on modulation frequency, but it is independent of amplitude of the carrier. Therefore, the third option is correct. So 1 and 3 are correct. For option B is the answer. The ratio of frequencies of the first line of Lyman series and the first line of Balmer series is. So here you know that the wave number is given by given by R 1 upon n1 square minus 1 upon n2 square, where n1 and n2 are principal quantum numbers. For Lyman, n1 is 1 and n2 starts from 2. And for Balmer, n1 is 2, n2 starts from 3. For Paston series, n1 is 3, n2 starts from 4. Then for bracket, n1 is equal to 4 and n2 starts from 5. And Fund series, value of n1 is equal to 5 and n2 runs from 6. So here it is asked to compute the ratio of frequencies, but this one is a wave number. So we know that nu is given by C by lambda, that is C into nu bar. So nu Lyman divided by nu Balmer is equal to nu bar Lyman divided by nu bar Balmer. So R gets cancels. So 1 upon here n1 for Lyman series is 1 minus 1 upon n2, that is 4. 2 square is 4 divided by, for Balmer it is 1 upon 2 square 4 minus 1 upon 9, that is 1 minus 1 by 4 divided by 1 by 4 minus 1 by 9, 36, 9 minus 4. So it is 3 by 4, 5 by 36. 3 by 4 into 36 by 5. Answer is 27.90. So it is 27 by 5. Option A is correct. 10 raised to minus 23 ampere meter square is approximately equal to, so it is a 1 Bohr magneton. Electronic spectra of molecules are observed in. So we know that the electronic spectra is due to the different electronic configuration of atoms in a molecule. Therefore, it is observed in UV visible region. Then vibrational spectra. It is due to the vibration of atoms. So it is due to vibration of atoms which is observed in infrared region. Then rotational spectra. It is observed due to the rotation of molecules about the center of gravity. Generally it can be observed in far infrared region or microwave region. Here for electronic spectra, so visible and it is observed in visible and UV regions. The Landau G factor for 3s1 level is, for 3s1 level Landau G factor, G is given by 1 plus J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2 J into J plus 1. Here value of L, since it is S state, value of L is 0, then 2S plus 1 is 3. That means value of S is 1. Then value of J, J is also 1 because it is L plus S or L minus S. Value of J is also 1. Then G can be calculated by substituting the value of L, S and J. So J is 1, 1 plus 1, 2 plus S into S plus 1, 1 into 2 minus L into L plus 1, that is 0, divided by 2 J into J plus 1, 1 into 2, 1 into 2, 1 plus 2 plus 2 divided by 4. So 1 plus 1, that is equal to 2. Option A is correct. The degeneracies of the J states arising from the 3pj term with spin orbit interaction are. So given that term is 3pj, that means 2s plus 1 is equal to 3, that indicates s is equal to 1. And for p state, value of L is 1, then value of J R, it runs from L minus S to L plus S. So L minus S is 0, 0 to L plus S 2. Hence values of J are 0, 1 and 2. Then degeneracy of a state J is given by 2J plus 1. Therefore, if J is equal to 0, then degeneracy is 2 into 0 plus 1, 1. Then if J is equal to 1, then degeneracy is 2 into 1 plus 1, that is 3. If J is 2, then degeneracy is equal to 2 into 2 plus 1, that is 5. Therefore, degeneracies are 1, 3 and 5. In HCl molecule, the 0 point energy is 0.18 electron volt. Then the energy gap between the two vibrational levels is. So here we know that vibrational energy is given by n plus half into h cross omega. Then energy gap between any two levels, delta E, is always constant, that is h cross omega. And here given that the 0 point energy is 0.18 electron volt. 0 point energy is given by half h cross omega. Therefore, value of h cross omega will be 2 into 0.18 electron volt. Therefore, energy gap between two energy levels. This is the energy gap between two energy levels, that is 2 into 0.18 electron volt. That is nothing but 0.36 electron volts. Option C is correct. You are shown a spectrum consisting of series of equally spaced lines. This could be Options are rotational spectrum of CO, vibrational spectrum of N2, NMR spectrum of CH4, then Mossberg spectrum of Fe3SO4. Let us check it one by one. The first one is rotational spectrum of CO. To produce rotational spectrum, the molecules must have permanent electric dipole moment. It should have permanent electric dipole moment. So here carbon monoxide is having permanent electric dipole moment, and this may be answer. Then vibrational spectrum of N2. To produce vibrational spectrum, there must be change in electric dipole moment. But for N2 is homonuclear diatomic molecule, the dipole moment is 0. Therefore, this is not possible. Then NMR spectrum of CH4 will give only one signal. This is because all 4 protons are equivalent. Then the Mossberg spectrum of Fe3SO4 is also not correct. Then we will left with rotational spectrum of CO. Now let us see whether it will give series of equally spaced lines. We know that rotational energy is given by BhC J into J plus 1, where B is the rotational constant. Here for J is equal to 0, rotational energy is 0, 0, and for J is equal to 1, E rotational is 2BhC. For J is equal to 2, it is 6BhC, and for J is equal to 3, it is 12B into Hc. That means the energy difference or energy spacing between two rotational levels here are 2BhC, and here it is 4BhC, and this to this it is 6BhC. Therefore, for J equal to 0 is 0, 1 it is 2BhC. So energy spacing here can see is 2BhC. For J is equal to 2, it is so 4BhC, and its energy is 6BhC. Therefore, in a spectrum you will get line due to 2BhC, and then 4BhC, then 6BhC. But here distance is 2BhC. That is the separation between any two rotational spectrum lines are 2B into Hc. Therefore, it will give series of equally spaced lines. Therefore, option A is correct. Thanks for watching. Hope you like this video. Kindly subscribe and share this video and keep watching.